In this video, we're going to talk about events, sample space, and probability. In probability, we use information about the population to infer the probable nature of the sample. Probability plays an important role in making inferences. So we're going to talk about a few important terms that will be used throughout Chapter 3 to help us make these inferences. Our first term is an experiment. An experiment is the process of observation that leads to a single outcome that cannot be predicted with certainty. The sample point is the most basic outcome of an experiment. Sometimes the sample point is called the sample space or simply the outcome. The tree diagram can be used in problems like coin flipping to help us illustrate all the possible outcomes of the experiment. A tree diagram is a drawing to depict possible outcomes in an experiment. At the top of the tree, there are branches representing the possible outcomes for the first observation in the experiment. Each of these outcomes results in more branches representing the possible outcomes for the next observation in the experiment, and so on. The sample space of an experiment is the collection of all its sample points. A Venn diagram is another example of how we can use a picture to represent our information or outcomes. The Venn diagram is a graphical representation for presenting the sample space and all possible sample points. We will be using the probability rules of sample points. These probability rules include the fact that the probabilities must lie between 0 and 1. So we can write that this way. 0 is less or equal to the probability, which is less or equal to 1. 0 represents 0%, and 1 represents 100%. So the only numbers that would make sense for our outcomes or probability of the outcomes would be numbers between 0 and 1. The probability of all sample points within a sample space must sum to 1. In other words, if you have more than one event, you need to make sure that the probability of those events will add up to 1, which represents 100%. An event is a specific collection of sample points. So we'll be working with references for classwork today that show you how to come up with different events for your experiment. The probability of an event will also be calculated. The probability of an event A is calculated by summing the probabilities of the sample points in the sample space for A. Next, we'll talk about the steps for calculating probabilities of events. The first thing is we need to define the experiment. In order to do that, we're going to describe the process used to make an observation and the type of observation that will be recorded. Next, we'll list the sample points. Third, we need to assign probabilities to the sample points. Fourth, we'll determine the collection of sample points contained in the event of intersect. And last, we'll sum the sample point probabilities to get the probability of the event. Let's look at a reference for classwork. In the first example today, you can see that we have this diagram. This is the Venn diagram, and it describes the sample space of a particular experiment and events A and B. So we have event A and event B. You can see there are some numbers within those events, and there are numbers that are outside of those events. The numbers that appear outside of the event are numbers in the universe. S is used just to show what the sample space is. So our sample space consists of this box representing the universe and the two circles representing event A and B. The first question says to suppose the sample points are equally likely. Find the probability of A and the probability of B. First off, we need to know what equally likely means. Notice that each data point appears only once in our universe and events. There are only 10 data points, therefore the probability of an individual data point appearing is equally likely, and each is 1 out of 10. The probability of event A means we're looking for the probability of the numbers 1, 3, 6, and 8 occurring. So we have the number 1 appearing 1 time out of the 10 numbers. So the probability of A is worth the probability of the number 1, the probability of the number 3, added to the probability of number 6, added to the probability of 8. Since each of those values appears 1 time only, each is worth 1/10. So we have 4/10, which we could call the decimal point 4. So we could actually represent our probability as the fraction 4/10 or the decimal point 4. For event B, we have the numbers 2, 3, and 7. So the probability of event B is the probability of the number 2 added to the probability of number 3 added to the probability of number 7. Each of those probabilities is 1 out of 10, so that would make 3/10, which we could also call the decimal point 3. Now we're going to change the value of each of those probabilities. So we're saying here for part B that the probability of 1 is equal to the probability of 2, which is equal to the probability of 3, equal to the probability of 4, equal to the probability of 5, and each of those numbers now is worth the fraction 1/20. And the probability of 0.6, 7, 8, 9, and 10 is now going to be worth 3/20. So in order to find the probability of A and the probability of event B, we're going to use these fractions now. So event A still contains 1, 3, 6, and 8. So I have to make sure I assign the correct fraction to each of those points. So probability of 1 is worth 1/20. Probability of 3 is worth 1/20. Probability of 6 is worth 3/20. And the probability of 8 is 3/20. So if we add these fractions, notice that we already have a common denominator of 20. So we're simply adding the numerators. 1 plus 1 plus 3 plus 3 would make 8/20. Or if you put that into decimal form, that would become 0.4. So now the probability of event A is 0.4. Using our fractions again for the probability of event B, we still have 0.2, 0.3, 0.7, but the new values for 0.2 would be 1/20, 1/20 is also 0.3, and 0.7 is 3/20. So when we add these together, we end up with either 5/20 or the decimal 0.25.